going to teach you how to count. 1, 2. I think this is section 5.4 in the textbook. So what is counting? If you go back and look at the examples that we did, each time we had to do a probability problem. I wrote the sample space out and I tried to count every single possible values and then found the probability. And that is too much because if you have 30 trials or 40 trials, then we don't want to sit and write every single possible combination out, right? Do you agree? So we have easier ways to just count the number of outcomes that are possible for any given experiment. So we would want to know the number of orderings that are possible with replacement. Last time I meant what with replacement means. In a sense, you can take something and put it back again. So let's just say that there are n distinct items. And we can call R slots or positions, and we'd like to know the number of distinct orderings that are possible if I have to do something with replacement. Can someone tell me how many are possible?
And R, you just multiply them together.
So R different slots or positions, so slot 1, slot 2, ... slots R. And each of them could have n possibilities because it's done with replacement. So the first one would get n items, the second would have n, the third would have n, all the way up to the last one. Still have n, so n gets multiplied to itself r times, so the answer would simply be n raised r. If we say we just have n items and we're going to make use of all n items, and we've got to put it in n different slots, but without replacement. How would that work?
I thought R was for slots.
Huh?
Is R not for slots?
I'm changing it to n now.
They're both N. How are they both
They're both
N?
n.
N times.
N times
N minus 1.
times
N minus 2.
times
N minus 3.
times
N minus 4.
she would not give up, so. What would that be? The n minus first,
Minus n.
n minus n, that would be 0. It can't have 0 items.
I'm so confused.
2, 1. Right?
Huh?
So
Oh, 2-to-1 ratio.
as an example, suppose I started with 5 items and I want to find the orderings, but I have to do it without replacement and put it in 5 slots. I'll start with 5 initially, but the next slot can only have 4 possibilities. Slot after that, 3. Slot after that, 2. Slot after that, 1. Right? Now, let's say you have 300 items and you want to evaluate this value. Do you want to set and write all those 300? No. This has a fancy little notation. And it is filled with excitement.
5 exclamation mark.
5 exclamation mark.
What?
What?
Example.
Byproduct. 5 exclamation mark has a name.
Factorial.
Factorial of 5 or 5 factorial. So you have a number of orderings and you go without replacement, you have n items and n slots, then we simply have 5 factorial. I'll just throw in a fancy name, permutations. And we have to do this without replacement. But in this case, we have n distinct items. And we have only R slots to fill. So, how would things change?
I take 5. Never mind.
It's the same process, but instead of going all the way to 1, where would I stop?
R.
Up to the nth term, so n times n minus 1, n minus 2, all the way up to n minus r. But instead of doing it that way, we have a fancy little formula.
Plus U.
Which is NPR, National Public Radio. No one listens to that. And the formula for that is n factorial divided by n minus r factorial. So if you keep on going, it'll be the r minus 1 position or the first position. So if you divide these two, it is going to tell us the number of orderings that are possible if you have n items and you want to put it in r slots without replacement. Suppose, yes,
What does P stand for?
thank you, great question. n permute R or n permutation R.
Could you move the computer down, please? I thought N was permutation.
Huh?
I thought N was permutation.
N is the total number of items. P stands for permute. So when you plug it in the formula, you'll get the total number of permutations that we could have. Lastly, we have combinations. So you have n items, and you have to choose R. In this case, order doesn't matter. What do we mean by that? Suppose you have a bag of candy and what is it, Jolly Rancher, and what was the other one last time? Skittles. So you have a bag of candy and I say, well, you just have to stick a hand in and grab 4 candy. And 2 of them happen to be Jolly Ranchers and 2 happen to be Skittles. Does it matter in what order they came out?
No.
No, because you're sticking your hand in once and grabbing 4 candy items out. So the order doesn't matter. In this case, we call it choosing, and the C stands for choose, so N choose R, and that is given by this formula, N factorial divided by R factorial multiplied by N minus R factorial. As long as it works, doesn't matter. So in your calculator, press Math and go over to PRB. What do you think that would stand? Probability. So you can see the options. If you want excitement in life, you go over there and choose number 4. Number 2 would give you NPR, number 3, NCR, and the 4th one would simply give you a factorial. Let's say I ask a question, okay, I have 10 different items, and you pick 2 out of those 10. In how many ways could it happen if order doesn't matter? Or let's say order matters, the permutations. So the first thing that you have to do is press 10, then go over to Math, PRB, option number 2, and I'm going to pick 2, so I have to. There are 90 possible ways. Good? So if I've said the order doesn't matter, yet you still have the same 10 items and you want to choose 2 out of the 10, then we have 10. Math. Over to PRB, option number 3, and 45 number ways, or 45 ways. And if you simply want to find the factorial, let's say we had 5 factorial earlier. If you want to find 5 factorial, 5, and Math. Over to PRB, option 4, enter. 120 ways. Does that make sense? Good? Okay. Suppose a device has a 5-digit passcode and each digit could be 1 through 9, any number, And we'd like to know the number of passcodes that are possible. In other words, we want to come up with the sample space. So, is this with replacement or without replacement?
With replacement.
This is with replacement. How many items do we have in total?
9.
9. How many slots do we have? 5. And we are looking for number of possible orderings, so what should we use? N raise R, NPR, or NCR? NCR.
No, I don't. PR.
N of them, and you're going to put it in
No, it'd just be NR, wouldn't it?
N raise R. How many digits are possible for the first slot?
9.
9. So I can put in 1 through 9. How many can I put in here?
9.
9.
9.
9. 9. Certainly we speak German. Uh-huh. And what is that?
59,049.
5,029.
No, 59,049.
59.
59049.
So we want to find the probability that only the first digit is 1. We're not computing the number of ways, we're actually looking for the probability. So we know the total number of outcomes that are possible, which is 59,049. How would we go about doing this?
Could you do the probability that the first digit is 1, which would be 1 over 9, and divided by something like the total? So it would be the probability of the 1 versus the probability of every other combination.
So your answer is 1 over 9 raised 6.
Wouldn't it be 9 over 59,049?
It's just 9 over 59. Boy.
Because isn't there only like 9 possibilities that only the first digit would be 1?
So if the first digit is 1, right? And only the first digit can be 1. The others cannot be 1, right? But they can repeat, yes. The ordering matters. So how many possible values would we have?
8.
8,
8.
8,
8.
8,
8.
8. So the total number,
Wouldn't it be NPR that we would have to use for this? Because, well, at least for the first one, since we can't replace the 1.
no, because I can do NPR for this part with n equals 4. But we can't do it for the entire thing.
Why would it be 8 instead of 9? Like, can't 1 also be an option?
Only the first digit is 1.
Yeah, but wouldn't that mean the rest, like, that doesn't exclude the possibility that another number is 1, does it?
It excludes the possibility that none of the other digits could be 1.
But I'm saying every other combination, 1 is still, couldn't be a part of it, like, it could be 5 1s in a row.
It can't be 5 1s in a row. The first digit is 1 and none of the others could be 1.
Yeah, wouldn't you have to include the other numbers being 1 in the following, like, probability?
No, the others are 8 possible ways here, 8, 8, 8 there, all of them excluding 1. Because I cannot have 1 again. 1 cannot.
Oh, you're doing the probability of success.
No, that's not what I mean. So, total number of ways in this case would simply be 1 times 8 times 8 times 8 times 8, 4 times 3 3 4. Yes? So the probability of that happening is 8 raised 4 divided by 9 raised 5. And what is that answer?
Zero point zero six nine three, or 694.
0.069.
694.
Okay, let's see if we can do this. So the key here is to recognize that these two could have all 9 possibilities, but the last 3 can only have 5. And we're using n raised r because we're doing it with replacement and we are trying to find the number of orderings. Suppose we have 9 digits to form a 3-digit passcode. How many codes are possible if the digits cannot repeat? In other words, once you pick a digit, you can't put it again. So, what type of problem is this?
NPR.
NPR. Why, Bailey? Enlighten us.
Because there's no replacement and the order does matter.
Total number of items in this case would be the total number of digits we have, which is 9. Out of those 9, how many slots do I have? Just 3. And the order doesn't matter. Excuse me, the order matters. But things are done without replacement. So this is a permutation problem. So are we looking for a probability?
No.
No. What are we looking for?
The number.
The total number of possible ways. So the number of ways, the total number of codes would be NPR, so 9P3.
504.
512.
504. Oh, I was like, what else did you give me? Okay.
So probability of A or B, or A union B, addition rule, probability of A plus the probability of B minus the probability of A and B. Right? So, what is the probability of A? probability of A simply states that the first digit is 2. So I'm fixing the first digit as 2, right? So I started with 9 digits. Out of those 9, I took care of 2. How many am I left with? Because this is without replacement. 8. And I want to take those 8 digits and put it in 2 slots. Agreed? Yes. Those are the 2 slots. So one way of picking 2, because the first digit is fixed to be 2, and how many ways do we have? 8. Permute 2. That should be the number of ways. And that would give me 56.
I did nothing like that.
So the probability of A is 56 divided by 504.
Where did the 504 come from?
Yeah, that's how
Oh.
yeah, this is how I tried to do it, and you told me no.
Now, would the probability of B be any different from the probability of A? No. If I just switch this, it's the same thing, so the probability is not going to change. The probability of A is the same as probability of B. Now we have to find the probability of A and B. Who can tell me what the probability of A and B is?
Zero.
What?
Zero.
0. Why is that 0?
Because you can't have both because they're without replacement.
Since the experiment is done without replacement, both the first digit and the last digit cannot be 2 at the same time. So in this case, events A and B are called
Mutually exclusive.
mutually exclusive events. So 56 over 504. So it is 112 divided by 504.
0.3 repeating.
So we want to find the probability that at least one of the digits is 2. Now, what does at least mean? One or more is 2, right? So we're pretty much saying, okay, probability at least one of the digits.
But more than one can't be 2.
Patience, Bailey. Trying to explain. So probability at least one of the digits is 2 would simply mean exactly 1 is 2. Or 2 of them are 2. Or all 3 are 2. Right? Now, any given time, these events cannot happen simultaneously, so I can split it up and write it as and this is where logic must come into play. just by looking at it, and based on the question, what is the probability that this could happen?
0.
Impossible, because when I first started, I said, well, they can't happen simultaneous, it's without replacement. So that's 0. That's 0. And you may argue, well, that's happening only one time, so the answer has to be 56 over 504. But that's not true. At least one of the digits is 2, simply means either this is possible, right? Exactly one of them is 2. Maybe I should write that. That actually means exactly one digit is 2. In how many ways could that happen?
3.
3 ways. But the probability of all 3 ways would be the same. Correct? So we already know from part 2 the probability of that happening is 56 over 504. Switch it around, same thing, 56 over 504, occurring 3 times. It's 1/3. So 33% probability. Could we have done this a different way? How?
3 over 9.
3 over 9. That's just fraction.
No, I know, but you just add like 1/9, 1/9, 1/9.
Yeah, that's what 3 over 9, but it's in a different way. There are multiple ways.
I did 1 divided by 9, 1 divided by 8, 1 divided by 7.
That's what.
Because in the first option, all 9 numbers are a possibility. The second option, all 8 possibilities are a thing, because you're not replacing it. So you basically, if you don't get in the first one, you have to calculate the possibility that it can be in the first one, it can be in the second one, it has to be in the third one. So if it was ever in the third position, you'd have to assume that it was not in the first 2 positions. And because it's just as likely to go into all 3, you kind of have to calculate the last one. I don't know if I explained that good.
I'm trying to understand, but I could follow the 8 times 7 part, which would give you the 56. And then you had,
So in the first numbers, there's 9 possibilities. And one of those numbers has to get chosen. So we're gonna assume that it's not a 2. So the possibility that is a 2 in the first number is 1 over 9. The second
Okay.
number, it can't be 1 over 9 because the first number was already chosen. So it'd have to go to 1 over 8 because it could still be a 2.
okay,
Assuming that it's not a 2, you go to the third number. Still can be a 2, but there's only 7 numbers you can choose from.
okay. So it's 1 over 7. So
Yeah.
if you multiply all those probabilities together, what would you get?
You get 0.37897.
It's not the same answer, is it? That's not correct. Okay, there is a rule that I talked about last time that relates at least 1 to you have to read, people. I said it is a very important rule, it plays a significant role, it relates at least 1 to.
If A is an event, then AC is its complement.
True. What is the complement of at least 1?
0.
None, right? So remember, I wrote probability of at least 1. Right? Probability of at least 1 is 1 minus the probability of none, because none is the complement of at least 1. None of the 3 digits that we have could be a 2, right? That's what that means. In how many ways could that happen? If I have 9 items 9 distinct items, and I formed 3-digit codes. In how many ways did that happen? That was the very first part that we did.
56.
56?
Nope.
You hear that down?
504.
What?
504.
504, 9p3. Now, none would mean none of the 3 digits could be a 2. So how many possibilities, how many orderings would I have? What is n now?
8.
8. How many 3-digit codes am I to form?
Not 504.
336.
So it would be 1 minus 8p3 because I'm choosing 3 digits from 8 digits because 2 cannot be one of the digits. Divided by the total number of possibilities would be 9p3. Yes?
Yes.
And what do you get when you simplify?
0.3 would be there.
Should still be 1/3 if you put everything together, right? Because this would be 2/3. So that would be 336 divided by 504, which would simplify to 2/3. 1 minus 2/3 would still be 1/3. Does that make sense? So you can either do it this way, or you can do it that way, which is easier. Okay, if you say so. I think this is easier, but that's just me. But I like both approaches. So the only key here is to recognize that those 2 events are impossible. So anytime you do a probability problem, you have to think of it, period. Spend some time and think, or write it out to get it right. So it's very, very important.